Here my setup is I have an MXG signal generator connected to my FieldFox. This is actually in the office. There's a splitter and some other cables in between them. It's part of a system. But the idea is to measure a clean signal. This is not really an over-the-air signal. And I will go ahead, and this is the Signal Studio for 5GNR. Just from the default setting, I'll change my frequency to 3 gigahertz just to have a different number. Let's do a minus 30 dBm power. Turn on the internal channel cal, make it flatter, and I like to change my cell ID just so I know it's actually working. Let's start with a narrow bandwidth. Let's start with around 10 megahertz to test this. And the rest of the settings we'll leave as is. So I will go ahead and download the signal. And over here, I will change the frequency to 3 gigahertz. And there is my signal. And now let's go into OTA. 5GNR, turn in the frequency, my 3 gigahertz. And there it is. And if I want to see the other beams, there it is, turn multi-beam on. Okay. The first thing I wanted to kind of go through is some power level changes because this is an RSRP of minus 61. You had a little bit lower power, so we'll go ahead and drop the power down. Let's do an increment set of 5 dB. And I'll just keep lowering this, and you can see this over here. If you keep looking, it's going to drop. 71, 76, 81. So far, so good. We're dropping the power. Minus 105 RSRP. And now it's having a hard time. It's really can't. Minus 110 is, So one of the, but we have 10 dB of attenuation, so we can go ahead and turn that off. That will help. And I may be getting to the limit of my source at some point. The other thing I can do, and it's not necessary here, but of course would be to turn on the preamp. And so that's kind of working. So now let's go into the 5GNR conducted mode. And we turn in the frequency, actually not the opposite, frequency 3 gigahertz. And I need to tell it the bandwidth. The bandwidth is 10 megahertz in this case. 10 megahertz. And I'm going to turn SSB auto detection off because it's faster. And I think this power should be okay. So this will pretty soon be able to detect the signal. Oh, actually, we left the power really low. Okay, let's go back to the original power level. Because for EVM measurements, you need higher power levels than that. So if we give this just a minute, there it is. These are your parameters. Now we don't have those bogus 100% EVM numbers. These are clean because this is a clean signal. We're feeding it what, we're telling it what it is. It's a nice conducted signal. So what I wanted to show you here is another feature that if I go into channel setup, and let's say I have an offset. So let's enter an offset for the SS, maybe 300 kilohertz, for example. Now if I go into this measurement setup, SSB, auto detection, oh, actually I have to download it first. Let me first download it, I forgot that part. Downloaded it, this is not on, and I turned SSB offset detection on. Oh, ADC overrange, that's too much power. Well, let's turn off the preamp. And there it is. So now it detected the signal, and there is your 300 kilohertz offset. And what you could do here is you could go to, I think it's mesh setup, results to setup, and export to 5GNR setup. And the idea is in a conducted measurement, you pick up the settings, then you come into 5GNR, and here it's entered these offsets right away, and now you can see your signal. If you don't know your offset and you want to use that offset detection. So now, again, I've picked a clean signal. If I had, where this stuff all didn't take as long, if I had a signal with a wider bandwidth, let's say 80 megahertz or even 50 megahertz, this process would take longer. It's just the algorithm needs more time. It's a lot more data, a lot more bandwidth to go through to test, to do this analysis. But actually, before we go there, I wanted to also show you just quickly that you could use VSA to communicate here. Let me go back to our, I guess we could let it be at this frequency. This will take a little bit longer. Where are we at? Oh, now we're back to 0, so we have to make this 0 again. And I don't think I told it. There it is. That's my 50 megahertz. But if you want to go into conducted, and I think I have to tell this that it's 50 megahertz. And let's turn offset detection off so it's a bit faster. And I think this will bring it up. But I wanted to bring up VSA because you can also communicate with it with VSA. Oh, this is getting kind of cluttered here, but I wanted to show this. So let's go ahead and just so this works smoothly. I'll go into the SA mode. And actually, you know what I want to do while that's doing it? I'm not an expert in VSA, so I'm going to take advantage of this and save this setup so I can recall it. So let's save it to desktop, this PC. Where is it? Let's put it on a network drive that I can. This one? Sorry, it's where's the network drive? It's not this. This one. Oh, this one. Okay. And let's see. Let's do 5GNR test. Okay. So here, let's preset all on VSA. And it already started talking to this analyzer. And just to make sure the signal is there, let's go to 3 gigahertz and auto scale it. And there's the signal. But I'm going to go ahead and recall my setup because it helps to get all the VMod stuff set up. And now this is talking, and it doesn't look very clean. It does want to cal, but let's first do an auto range. This just takes a minute. And we have some network speed issues in addition that VSA just needs to do the auto ranging for the whole band. And there it is. There's your nice clean signal. And this is the same kind of parameters that you would be seeing. It's the same algorithm that you would be seeing in the FieldFox OTA app. So I just wanted to show you, there's my cell ID of 300. And so I wanted to show you that you could do this with VSA, or you could use it directly on the instrument. And that's about it.